All right, so this is chapter 11, section 2, surface area of prism and cylinders. Your learning objective for this section is that you'll be able to find the surface area of a prism and a cylinder. All right, we have this nice little triangular prism. And a prism, the definition of a prism is you have a polygon on the bottom, its exact match on top, and it has rectangles all around its lateral, all around the sides. So we look, even though this prism is on its side, we still say that the triangle in the front and the triangle in the back is the base. So don't be fooled by how your prism is positioned, because the two items that are matchers on each side of the prism, those are the bases. All right, so we're going to label the missing dimensions of this triangular prism, and we're going to use a net. So when we look at our net, we unfold this. We have our triangle at the top. When we unfold it, we see that this 5 is also attached to the rectangle that is on the sides. And this 6 is for the big rectangle in the middle. It has a length of 6. This 12 here is the dimension for all of these, the heights for my rectangles, and that's 12. And the 5 gets to be each of the sides of my triangle at the bottom. So we're going to take a look at our triangle. I'm going to redraw it here because something amazing happens. When I draw the altitude of my triangle, it's the same. Altitude and the height of my triangle are the same. It forms a right triangle. So if I look at just the right triangle, we have 3 for our bottom leg, 5 for our hypotenuse, and we don't know what for our altitude. So we're going to use the Pythagorean theorem to find A. So we go 3 squared plus A squared equals 5 squared. We're going to square the 3 and the 5, and we're going to subtract that 9, because 3 times 3 is 9. Subtract it from both sides. 25 minus 9 is 16, and to find A, I just take the square root of 16. So we are going to find the surface area of the prism. Now, this is formula for surface area of a prism. Please highlight it or write it onto the margin somewhere so when you go to take this quiz, you have the surface area. Surface area is the lateral area plus the area of our bases. So the area of 2 lateral rectangles plus the areas of 2 lateral triangles plus the area of our base is. So we look the area of A and C, because these 2 rectangles are the same, A and C. Area of D is this top triangle. That's the reason we had to find the height of that triangle, because area of a triangle is 1/2 base times height. We needed that height. And there's 2 of them, a top and a bottom. And then area of B is that big rectangle in the middle. So let's fill in the numbers. We got, for area A, we have 5 times 12. That's the area of that rectangle. Plus another 5 times 12, because it's the same area, both of them. Then we have a 1/2, so we're going for the triangles. 1/2 base, just 6, times the height we found is 4. And there are 2 of those. Plus the area of B, which is 6 times 12. All right, so we crunch those numbers into our calculator, and we get 60 plus 60 plus 12 plus 12 plus 12. At the end of the day, that is equal to 216. So the surface area of the triangular prism is 216 centimeters. Okay, so we need to, in your quizzes and tests and on your standardized tests and for the rest of your geometry experience, we're going to need to know the difference between the lateral area and the surface area. So our lateral area for a right prism, so the proper conditions have to be met, is the perimeter times the height. And if you notice, that's different than the surface area, which is the lateral area plus 2 times the base area. So B stands for base area. I guarantee you, probably a fourth of you, 25%, will put in the base of a rectangle or the base of a triangle instead of the area of the base. Big B means the base area. All right, so if we put that together for a right prism, the surface area is perimeter times the height, which is the lateral area, plus 2 times the area of the base. And that makes sense to me because I think a prism has same base on top as on bottom. There's 2 of them. I need both of those areas plus all the area around the prism. Lateral area is like the area you get when you hug. You get all this lateral area hug. You don't get the feet, you don't get the top of the head, but you get all around it. All right, so we're going to look at this nice little hexagonal prism here. We want to find the lateral area first because it tells us to find the lateral area. Be careful as you guys are working that you read the instructions carefully. They're going to shift back and forth between lateral and surface area. So we're going to find the perimeter of our base. That would be 6 plus 6 plus 6 plus 6 plus 6 plus 6, which is equal to 36. The height of the prism, this is where it gets crazy. So this prism is on its side. So the height of the prism is the distance between its 2 uniform bases. So because it's on its side, the height is horizontal, so don't get confused. It is 12 for a height. So the lateral area is 36 times 12, or 432. The lateral area of the prism is 432 meters squared. Okay, now we're transferring our brains. We are not doing prisms anymore. We are doing cylinders. So we're going to take the formula for a prism and apply it to a cylinder. So we want to find the lateral area. So think about, I'm hugging a cylinder. The lateral area around a cylinder, if you were to unfold a cylinder and just take the outside part, what shape do you get? A rectangle. So a cylinder when you look at its net, it's actually two circles and a rectangle, because this wraps around, the rectangle wraps around and touches the circles at the top and bottom. So we want to find the lateral area is going to be whatever the circumference is around the circle. And then the height of your rectangle is going to be the same as the height of your cylinder. So the area of your lateral surface, of your lateral area, is going to be 2 pi r times h, base times height. And then what is the area of circles? It is just pi r squared. So for this particular cylinder, so let's highlight this because it's actually the actual real formula for a cylinder. We're going to use this over and over again. So we're going to substitute 10 in for the radius and 9 for the height. And then resolve those. 2 times 10 times 9 is 180. And 2 times 10 times 10 is 200. We're going to have our answer in terms of pi. So when you're asked, and you will be asked, to leave your answer in terms of pi, the pi hangs on and you just use it like an x, like a variable. So 180 plus 200 is 380 pi. So the surface area of the cylinder is 380 pi centimeters squared. All right, a stencil roller has a height of 1.5 inches. So make sure we draw a picture. It's got a height of 1.5 inches and a diameter of 2.5 inches. What area does the roller cover in one turn? So am I talking surface area or lateral area? Does the side of my roller at all touch the stencil paper? No, think about rolling something. And the sides don't touch at all, so we are talking lateral area. So the distance that's covered in one turn is the circumference of the circular base of the cylinder. So the circumference times the height is going to be our lateral area. So when we go pi times the diameter, that is pi times 2.5, which is the diameter, times 1.5, which is the height. So that gives us approximately 11.78 square inches. And it does say round to the nearest tenth, so the roller covers about 11.8 square inches in one turn.